Hello, let's all jump game 3, which is LC1306. The problem says given an array of non-negative integers ARR, you are initially positioned at start index of the array. When you are at index I, you can jump to I plus ARR of I or I minus ARR of I. Check if you can reach any index with value 0. Notice that you cannot jump outside of the array at any time. What does this statement mean? Okay, so this statement means that if I am at index 0, let's say, then I cannot perform this operation because going to this operation would lead me to an index which is outside the bounds of the array, right? So that is one thing. And I can see another observation over here, which which says that if I have reached an index, uh, it is not necessary for me to reach that to visit that index again. To consider an example, let's say I'm currently at index 4 at index 0, and the one possibility is I reach index 4, which is here. Now from here I have two possibilities again, right? To go to index 0 or go out of bounds. And obviously out of bounds is not possible. So the only possibility is to go to index 4. Now if I go to index 4, there is again the same possibility that I go to 3, and this recursively goes on. So one thing is for sure, that I'm not supposed to visit a visited index again. And the another thing is I have been given a starting point. I don't know the path. I know a destination, but that destination is not very certain, which means the destination is an index which contains a value 0. So I myself will have to construct the path, but for every index, I'm having like two paths, right? So let's say if I'm at this index, I'm having I minus I plus ARR of I or I minus ARR of I. So this looks a lot more like a traversal problem in a graph where you have been given a starting index and you are supposed to start from the start index and traverse all the way by checking the value of every single index, and whenever that index is 0 you return it as true, and if it after traversing the entire graph, if you think that there is no index possible, you return it as false. Yeah, I think this one should work. Let's try and code it out. Let's start off with n equals n of ARR, and I will have to create a graph here. Dot default dict. Let's cool. Let me traverse the array once. Okay, and on traversing now comes the part on how I'm supposed to construct the graph, right? So there are like two possibilities. Possibility one is to go behind from that node, from that index behind, and another possibility is to go forward from that index. And if I go behind, it is I minus AR of I, and if I go forward, then it's I plus AR of I. And now to construct the graph, I'll have to check for conditions here, right? If behind is greater than or equal to 0 only then I can go from this index to the behind index. And if my forward is less than n, only then I can go from this index ahead, right? So this is one thing. Well, I think we have built a graph, and now we can start a breadth first search traversal through the graph, looking for the value at every single node and check if it's 0. Anytime it's 0, you return it as false. Otherwise, you complete the traversal and you return. I mean, whenever you find the value at certain index as 0, you return it as true. If you don't find any such index throughout the traversal of the graph, then you return it as false. And also you need to have a visited array so that you don't visit the same index or node every single time. So let me start the BFS traversal. I define a queue over here and a visited set. My I would start off with the start index, and obviously the start index is already visited, so I'll have to add it in the visited set or complete the BFS until the queue is not empty. You take the node and pop it out, and if the value of that node is 0, then you return true. Otherwise, you continue the traversal with the along the neighbors of the graph. And graph of node. If if neighbor is not in neighbor not in visited, then you add the neighbor into visited and you append that to the queue, right? And if after the traversal you don't find any such index, then you return it as false. So let me go through the code once to ensure that everything looks fine. Yeah, everything looks fine. Let me run it once. Oh, okay. Apologies. This is supposed to be a DQ. Right? Cool. Example cases are passing. Let me submit this. Cool. This one works here. I was also wondering if visited is actually required because no, no, I think it's required because you in the graph construction there is both forward and backward. Yeah, so visited is required because you will obviously have an option to come back to the same index again. Yeah, so visited is required. It's passing. Yeah, so that was it for today's problem. Any doubts, do let me know in the comments. Thanks.